What activation function should you use for better model performance? Imagine building a machine that learns from data and gets smarter over time. The secret sauce lies in how each tiny part of the machine makes decisions. That's where activation functions come in. They decide whether a neuron should be activated or not, shaping how the network learns. Without them, neural networks would just be simple linear models, unable to grasp complex patterns. The most common activation function in hidden layers is the rectified linear unit, or ReLU. It's simple. If the input is negative, output 0. If positive, output the input itself. This helps models learn faster and avoids problems called vanishing gradients, which slow down learning. ReLU is popular because it's quick to compute and works well in many cases, especially in image recognition tasks with convolutional neural networks. But ReLU has a flaw. Sometimes neurons stop learning altogether if they keep outputting 0. This is called the dying ReLU problem. To fix that, developers created variants like Leaky ReLU. It allows a tiny amount of information to flow even when the input is negative, keeping neurons active. Another option is the exponential linear unit, or HELU. HELU can improve learning speed and accuracy, especially in deeper networks. There is also Swish, a newer activation function that is smooth and non-monotonic. Swish has shown better performance in very deep networks with more than 40 layers, making it useful in advanced AI models. When it comes to output layers, the choice of activation depends on the task. For predicting continuous values, a linear activation function is used because it outputs raw numbers directly. For binary classification, where the goal is to decide between two options, the sigmoid function is common. It maps outputs to probabilities between 0 and 1. For tasks with multiple classes, softmax is the go-to. It turns the raw outputs into a probability distribution across all classes. For multilabel problems, where multiple labels can be true at once, applying sigmoid to each label independently works well. In recurrent neural networks, which process sequences like speech or text, functions like tan and sigmoid are often used inside the network to help model the timing and order of data. Recently, in large language models like ChatGPT and BERT, the Gaussian error linear unit, or GELU, has become popular. GELU combines properties of ReLU and dropout, giving smooth nonlinearity that helps improve performance in language tasks. In practical AI applications like ChatGPT, DALL-E, or Midjourney, choosing the right activation function can make a big difference. It influences how efficiently the model trains and how well it generates accurate text or images. Many AI tools and plugins optimize model performance by selecting activation functions suited to their specific architecture and task. So if you want your neural network to perform better, start with ReLU for most hidden layers. If your network is very deep or complex, try HELU or Swish. For output layers, pick sigmoid for binary tasks, softmax for multiple classes, and linear for regression. For advanced natural language models, GELU is a strong choice. Remember, experimenting with different activation functions can help you find what works best for your specific project.